Now the good part. We get to introduce our BFFs, Dr. Amy Noel Parks and Dr. Macy Gholson. Their resume is ridiculously long. We're not going to go through all of the things. Just know that they are epic on so many levels. They help us with the work, both in tool creation and thinking about what we might need and reflecting on where we're at and getting us to where we need to go. In addition to that, they're just great people. Welcome them to the stage, Dr. Gholson, Dr. Amy Noel Parks.
Do we each have one of these?
You want me to have this?
Yes.
Okay, great. Good morning. How's everyone? I think we're ready to get started. This is exciting. Usually I'm with my other partner in crime, Dr. Deborah Ball, but this year I get to present with Amy Parks. Yeah. Woo. I did that. Okay, you guys. Here's what we're going to talk about today. Can you see?
Can we have slides? There we are.
Okay, so we're here and here. Great. So the title of our presentation today is Little People, Big Ideas. And so the subtitle is really important because we are at an early math conference and we think of little people, but we often don't give credit to their ideas. And so part of what we're trying to do today is learn to respect and play with children's mathematical thinking. So, Amy has a task for you already.
Okay, so we're gonna start because we wanted to bring math into the room early with a little choral counting activity. So I assume lots of you are familiar with this, but if you're not, this is an interactive number sense routine that you could do in classrooms with kids, I mean, all the way up through college, so pre-K to college. And the way this works is we're gonna count together. And when I introduce this to kids, I say, you know, like when you sing a song, the goal is not to get to the end of the song as fast as you can, right? The goal is for all of us to sing together because it sounds better. So we're gonna be counting together. I'm gonna record our count, so I need us not to count faster than I can write. And to give us a little bit of challenge as adults, we're gonna be counting with fractions. So our first choral count is we're gonna count by fourths. And we're gonna start with 1/4. And the way we're gonna name these fractions is we're gonna use mixed numbers. So when we get to 1 and 1/4, we're gonna say 1 and 1/4 instead of 5/4. And we're gonna keep going until I hold up my hand, and that's when we're gonna stop, okay? All right, here we go. Ready? 1/4, 2/4, 3/4, 1. 1 and 1/4, 1 and 2/4, 1 and 3/4, 2. 2 and 1/4, 2 and 3/4. No, well, sorry, 2/4, Maisie.
That's what I said. I said 2 and 2/4.
She knows I was really anxious about doing choral counting with fractions up here.
I wasn't wrong.
Teacher.
Was I wrong?
We are going to talk about that later, friend.
Oh, okay.
All right, 2 and 3/4, 3. Okay, good. And now we're going to do another one just real quick. This time we're going to count by 2/3. Okay? So we're going to start with 2/3.
Did you hear that? It was, ooh.
I know. That's how brave I am. Okay, so starting with 2/3. Ready? 2/3, 1 and 1/3, 2. 2 and 2/3, 3 and 1/3, 4. 4 and 2/3, 6. All right, thank you. Okay, so Maisie raised this question. with our like naming convention on 1 2/4, and she said, "Well, isn't that 1 1/2?" And so if I was with kids, we would have a conversation about that now, right? I might do a turn and talk and ask you, talk about like, was Maisie right when she said that this was 1/2 or not? I might ask kids, what patterns do you see in the count? But since I'm not with kids here, I'm going to do something else, because the reason I wanted to start with this is because we're asking you to take little kids' ideas seriously. And I think some of us take for granted the intellectual work in learning to count for the first time, learning to count whole numbers for the first time. And my hope in starting with a fraction choral count is that it would unsettle that a little bit, and you would have to do some intellectual work to do the counting. Can I get the next slide? Okay, so instead of actually talking about, our patterns up here, what I would like you to do is to talk at your table. It doesn't have to be all of these questions. You can focus on the one that's most interesting to you. But how did counting with fractions change the cognitive demand of counting for you? How did it call on, challenge, or build on your knowledge of fractions? And how did it make you think differently about how young children learn to count whole numbers? Go ahead and do that for a few moments.
I thought I was intentionally trying to be disruptive.
I thought that was intentionally disruptive.
I know, but I thought I was being helpful.
No, it's good.
Okay. It's like, this is too small for me to see here. And then this, I have to go like this.
Well, and you never know what's behind you.
Yeah.
Like I do hate that about this.
Here.
And I don't like being in control of when it's there and when it's not. Like, I understand they want to show us to the faraway people, but it's like, it is disconcerting to me to turn around and like not see my sheet.
Yeah.
Okay, I'm done with this.
Oh, I was gonna. Also, if you think I can do turn and talks, just let me know and like wave at me.
Okay.
Yeah.
All right, can I bring us back together? Thank you. My daughter's now 16, but at her elementary school, they did Focus Fox. That was their little hand signal. I wonder if we might get like 3 people just to share an insight that came out of your table. I think I'm going to leave it pretty open-ended. And if you raise your hand, someone will run a mic to you.
Oh, okay. I guess me first. We talked about the speed, how, especially with the 2/3, like it was almost too fast, and we really had to slow down. And keeping that in mind with younger children, if you're counting by ones, I can count by ones fast, but if they are thinking about it, how important that speed is.
Yeah, so slowing down and recognizing that the reason we need to slow down is because there is intellectual effort going on in the process. It is not rote.
So I'm from the world of pre-K, and so for me it was really like when I heard we were doing by fractions, I felt a little anxious.
Same.
I'm like many people in the room. But again, when you flashed a visual though, right before we started counting to remind me what does 2/3 look like in terms of a whole, or what does 1/4 look like in terms of a whole, it gave me confidence. So again, kind of that idea of that cognitive demand and how we're using visuals to make math visual for children.
Great. So thinking about what are the supports we can give for kids to help set them up for success and make the connections. Last one.
Oh, I was gonna
ahead.
like pick on some things. because I'm not convinced that you all were actually exercising any cognitive demand. I heard you go 2/3. Wait, how did it go? 2/3, 1 1/3, 2, 2 2/3, 3 1/3, 4. And what were you then trying to add 2/3 to each one of those? What were you doing? You're using rhythm, you're using, say again? The pattern. So I don't know. I think it's interesting, something we might want to pay attention to as we think about this notion of counting.
I wonder if that also depends on the background knowledge of people coming in. So for some of us, these fraction patterns may be automatic. And for some of us, we may be adding them in our heads as
But if
we
we're
go.
sing-songing them, we might just be singing them.
I mean, I think I guess the connection that I would make is if you were doing this with a class and you're hearing that sing-songing, it's probably not every child in your classroom who's doing the sing-songing, right? So some people are doing that and that's loud, and others of us are trying to keep up and doing this work, right? So always when we're working with a classroom of 20 or 25 students,
Or 300 people.
or 300 people, pre-K to like high school math, like people, like the task is not going to be the same for everyone, right?
I'm just putting a marker there because I think we're going to hit on parts of what I'm trying to lay out in a second.
Yeah.
But I like the pushback, and we had a third comment, so
Okay.
yeah.
So I want to add on to what Dr. Gholson, you just said. Like, I have never before in my life, adult life, had to count by 2/3. And I never really noticed the pattern, never written it down. But as soon as I saw that second row of
Got this.
numbers, I'm like, oh, yeah, I see the pattern. Yeah, it's easy.
Interesting.
Okay.
Do you want me to push forward?
Yes.
Okay. This is what happens when Amy doesn't send me a photo, is that I see what, the latest AI generator thinks I look like and what Amy looks like based on our profile pics. But for those of you, again, more formal introductions, Dr. Amy Noel Parks at Michigan State University, professor there, who is just one of like a mentor and friend that I really enjoy her work. I am Macy Gholson, associate professor at the University of Michigan. So this is us in Simpson land. But we hope.
I feel like given our previous conversation, I want to say something about our background too.
Oh,
so
sure.
like I was a journalism major in college. I didn't have to take a single math class. And I went and I did a teacher ed program after that. And I took one algebra course at the community college because that was what I had to take to get certified. And then I taught elementary school. Maisie, do you want to say what you did?
I'm an electrical engineer and computer scientist by degree. And I had so many lives. I was a patent writer, so I wrote patents for a little while, and then taught, and everything they say about lawyers is true. Sorry. And then I taught high school, trying to find myself, and I did. And then since then, went to grad school and now at U of M. But yeah.
So we have different perspectives on like the cognitive demand of like a fraction counting task. I think it might be located in that.
Oh my gosh, come on. But also some of the math that those of us that took advanced math courses, we're gonna do some advanced math later today. So I hope you stay excited about that. Yeah, okay. So we're gonna ask 3 really big questions. First, we're gonna ask, what is counting? And we're gonna do that to begin to appreciate the complexity of it as a practice in children's mathematical learning. Then we're gonna ask maybe what sounds like a strange question, which is, what makes counting mathematical? Because the argument that I was trying to make a little bit earlier that was co-signed by my friend in the back was that counting could be thought of as a kind of like cultural practice that may not necessarily have mathematical entailments. And so what makes then counting mathematical? And we're gonna do some deep exploration of that. And then we're gonna end with thinking about how do we take all of this into account in our work with teachers who are working with children in classrooms. Anything to add there, Amy?
No, that's perfect.
So here's a question. What is counting? And I'm gonna play a video for you. It's super adorbs, but it is also long, so we're gonna break it up into a couple of sections. Okay, so this is Aaliyah, and I'm gonna try to hit play, and we'll see what happens.
4, 5.
No, that's 1, 2, 3, 4.
No, 1, 2, 3, 4, 5.
No, 1, 2, 3, 4.
No, it's 1, 2, 3, 4, 5.
No, that's 1, 2, 3, 5.
No, it's not 1, 2, 3, 5. It's 1, 2, 3, 4, 5.
Okay. That video is about 2.5 minutes long, and they do that for a really, like, Dad's like, no, and she's like, 1, 2, 3, 5, and they do that for a fairly long time. But here's where we get to, okay? In
It's 1,
Okay.
1, 2, 3, 5.
It's 1, 2, 3, 4.
No, Mommy, it's 1, 2, 3, 5.
All right, count to 4.
1, 2, 3, 4.
Yeah! You did it!
4,
Point
5,
proven.
6, 7,
Yeah.
8.
Yeah.
So what's awesome is Dad says point proven, and then Aaliyah's like 5, 6, 7, 8, and it's so fantastic. So what's going on here? Okay, how can we appreciate what Aaliyah's up to? And I'd like to see this slide because I talk through the slides and these are too tiny. Thank you. Okay, so when we think about counting, generally in research, there are two kinds of perspectives that we bring to this. Deborah and I have talked about this as the acquisition model and the participation model. Here we could think about it as a schema in the mind, which is that is what we believe in cognitive science, the English and Halford piece, is what should be in children's minds as they are developing the concepts of counting. And then we could also think about counting as a cultural activity. And the reason there's an asterisk next to a cultural activity is because that's actually the one we can do. Anybody in here a mind reader? I mean, can you see into your kids' heads? And do you think if you could see into their heads, that would be what you would see? No. But these are cognitive psychological models, and then we have other models that are thinking about what's happening when kids are counting. Amy, you gotta tell me to like, keep going, Macy, because I will just sit on a slide.
I don't have a watch, so we could be here
Okay,
forever.
so I'll just take my time. But the point that I wanna make is that counting is a non-trivial activity. It feels pretty trivial to you all. Come on, let's be real. Can I get give me some action, y'all. It's Monday, all right. But it is a non-trivial activity, and I'm gonna put some labels on things to help you appreciate that. So there are mathematical elements and there are literacy elements, and together, those elements form what we call a semiotic system. And semiotic system is just a fancy way of saying that there's signs in the world. Those signs are the things that we say, it's how we read, it's how we write, it's how we signify. So signaling with your hands, 1, 2, 3, 4, 5, is a way of thinking about literacy. And so what I'd like to do in order for us to appreciate the non-triviality of this is to think about 3 views of Aaliyah's counting. We're gonna think about it from an everyday perspective, we're gonna think about it from a conceptual activity, and then we're gonna think about it as a teaching activity. You ready? Doing a lot of talking at you. Okay, counting as an everyday activity. All right, so Aaliyah is able to say 1, 2, 3, 5. She's saying numbers. She's also trying to do this, but do you see that like stabilization side and skill side, that gross, that fine motor stuff? So she can't make the signs yet, but that embodiment, that development is also something that's mediating her counting. And so what I want to convince you of is that counting in this sense is essentially just a literacy. It's just a cultural activity, okay? And what I mean by that is there are all different kinds of sign systems, and that's part of what she's playing with, is the literacy components of that. And so I took notes because I can't read this tiny, but A is how they sign 1, 2, 3, 4, 5 in Europe. B is guess where? US. C is in Iran. E is, or D is American Sign Language. E is on the hand signals as Papua New Guinea. But then that's just in the base 10 system. But if we think about the Okasapan people, they are a multi-base people, and all of your digits and joints have different meaning. So the way that we sign number is deeply connected to our culture. Guess what else? The way that we say number, deeply connected to culture. These are literacy activities. So think about, in this structure, this is in Mandarin, and I don't know if we have any Mandarin speakers in the room, but I'm sorry as I butcher Mandarin. But think about the unit digits and how they are said. So notice that means 2. But how do you say 20? She. I know I'm saying that wrong. Okay? So 2 sets of 10. Right? We talk about this in Spanish a lot, but in Mandarin, it's really clear how the mathematical structure is built into the language. So when a kid in the US says 11, do you think they're putting together that that's a 10 and a 1? But the possibility is greater that that's happening here because it's built into the linguistic system. So how do you think we would say 57? Yeah. I just hear I think you're zeroing in on it, right? So there are ways in which this cultural activity has the mathematics in it, but certainly kids could be reciting numbers and not understanding anything about the math structure, right? So now let's move to math as a conceptual activity, okay? So this is answering the question, what makes counting mathematical? And when we think about counting as mathematical, this is kind of what we see in Aaliyah, that she is saying 1, 2, 3, 5 over and over and over again, okay? And in your look book, so you can pick that up. Thanks. There's a definition of counting. And I'm gonna zero in on one element of this, and then we're gonna watch another video, and we're gonna see some other elements. But one of the things that really comes to light in Aaliyah's video is this idea of a counting sequence, right? And stable order. And so what we mean by a counting sequence or a stable order is probably how we'd say it in the research literature, is that number words are used in a fixed order. That is, the number word has stability, so you say them every single time, and ordinality, you say them in a specific order. Got it? So those are the things that kids are having to pick up on. That doesn't feel extraordinary to you? Both of those parts? But think about it. Think about what do we know about what Aaliyah knows as a counter. Okay? We don't know much about one-to-one correspondence because she's not pointing at anything, or cardinality, or abstraction, or order irrelevance. We're gonna get to what those things mean. But we know something about stable order.
Can I jump in there
Yeah.
too? Like in terms of thinking about how challenging this is, think about the difference between learning to count and learning the alphabet, right? Because we learn to recite the alphabet in a stable order because it's easier that way, but there is no meaning to it. A isn't first because it's smaller than Z, right? A is just first. The vowels are like scattered randomly throughout, like, who knows why? I mean, I'm sure someone knows why the alphabet is the way it is, but like, there's no way to discover it, right? Whereas the order of numbers, like the sounds we say might be random, But it does have meaning that we say 1 first and we say 5 later. So kids are learning both these systems at the same time, and they both have different underlying logics. Just to reinforce what children like 2, 3, 4 are doing and how hard that work is.
Yeah. And I think the thing that's really awesome about what we learn about Aaliyah is that she gets stability, right? We can be curious about how she's constructing ordinality, like where did 4 go? Amy has a theory, right?
Yeah, I do.
Okay. Let's go to the teaching. Okay, let's move forward then, because I want to get to Amy's theory of what's happening. So let's think about counting now as a teaching activity that combines both those literacy elements, how we say, how we sign, the culture, and the mathematical parts of it. So what are the different features of one-to-one correspondence and what do we call it? Stable order, right? So let's think about it now through that lens, and let's look at Dad. Dad says, no, sweetie, it's 1, 2, 3, 4. Aaliyah, no, it's 1, 2, 3, 5. And then Dad says again in a very teacherly tone. Oh, Dad also says at some point, I teach about this every day.
Yeah. How are
it
you
was
doing
fantastic.
this with me? That's the first thing he says.
Yeah, yeah.
It's great.
And then he's like, I'm not gonna keep arguing with you. And then they like do it for like a minute, a solid minute. It's awesome. But then Dad just says, no, it's 1, 2, 3, 4, 5. And Aaliyah says, no, it's 1, 2, 3, 5. How many of us have seen, this is a mode of teaching. This is an orientation to teaching, right? And then we can think about, and we're gonna come back to that, but we can think about mom. And this is not to say mom, dad, like that's not, it just so happens in this video, this is what happens. But we hear mom's voice and she makes a really interesting move. She's like, all right, count to 4. And what happens when Aaliyah counts to 4? She magically arrives at 4. And mom's like, yay, you did it. And dad says the point proven. And then she's like 5, 6, 7, 8, right? And moves on quite happily. But the point here is that we have seen this the only way, and I think what I'm so impressed about in this video is not Aaliyah, I think it's her steadfastness in her own idea about what the number order should be. And in order for her to receive Dad, the identity work that's necessary for Dad's direct instruction is for what you think and say not to matter at all. In order for her to acquire that, she has to then abandon a way in which she is making sense of the world and just assume Dad's because Dad is, he's Dad. He's got power, he's got authority. So think about this orientation versus this orientation to how we get Aaliyah to feel or experience something different with respect to numbers and counting. And you have a theory.
Yeah, so and I don't know because even the whole video is like 2 minutes, but I think Aaliyah has a pretty stable count for 1, 2, 3. I think those numbers make sense to her. And I think she has an initial understanding of cardinality. Mm-hmm. So when you say count to 5, she thinks I have to land on 5, regardless of how long it takes to get there. When she says count to 4, I have to land on 4, and she knows that 1, 2, 3 comes first, right? Now, I don't know whether this is right or wrong, but it's a hypothesis I could continue to test if I was with her, right? I could ask her, count to 6, and if she said 1, 2, 3, 6, I would start to feel pretty confident that that's what I was thinking. If she did something else, I would have to have a new hypothesis. But what I like about the move the mom makes is that, and again, I don't know what the mom is doing. This is to Maisie's point, we're not mind readers, but it's providing us new data to shape our interaction with her. Like, I think it is at least potentially motivated by a curiosity about how Aaliyah is thinking about number, as opposed to a desire to have her say out loud the right answer. Right. And I think so much teaching I see across content areas in elementary is about how can I get the most children to either say out loud or write down the correct answer? there is so little curiosity about how children think about the world. So it's a mathematical problem, yes, but for me, it's a much broader problem, and I think that's the heart of what we're trying to get at here.
Yeah, and I think the other thing that I want to emphasize and put an exclamation point is that if she was able to recite what Dad told her to recite, we know then that she's just participating in the cultural activity, in the literacy activity of repeating something. We have no evidence that that has any mathematical bearing. So the idea that if we just get kids to say a thing means that they're participating in the cultural part of the activity or the literacy part of the activity we're saying and signifying and understanding the sing-songy nature of something, how it goes. But we don't have evidence of what it means conceptually and mathematically. And that's a distinction I think worth making. And we're gonna move forward.
1, 2, 3, 4, 5.
I'm gonna show it twice, so you can do it now.
Yeah, so the next question is, what makes counting more mathematical or mathematical? We're gonna dive into Elijah's video.
Okay, so you saw the introduction to that, but Elijah is a preschooler. He was playing during a free play time with a collection of bugs. His teacher walks by and says, "Oh, how many do you have there?" Video picks up as he starts to answer that question. It's only like 20 seconds long, so I'm gonna have you play it twice, but I'd like you to watch Elijah, thinking about what we just did with Aaliyah, and ask yourself, what can we see about his counting in this interaction?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay, count again.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good job. How many you have?
10.
Good.
Okay, go ahead and just talk again at your table about what you saw.
So the next slide is gonna
It's
have,
the chart. Okay,
Yeah.
perfect.
and we'll do order, relevance, and abstraction.
Okay.
You got that?
Yeah, I can do it.
Yeah.
And you can jump in if.
Yeah, am I over talking? Okay,
I think it's good.
okay.
I mean, I think having the cute videos helps.
Yeah.
You know what I mean?
It's
Like,
a little. Oh, we're doing really good on time.
perfect.
Yeah.
I'll let you be in charge of that. I just stop until Rusty starts to look anxious. And I'm like, oh, it must be time for me to be done. But the result was like the last one we did in Lansing, I went like 20 minutes over.
Oh no.
He was like, no, it's fine. We'll just remove this other thing.
So chill.
Sorry.
So chill.
All right, let's come back together. And can I go to the next slide? Instead of having people share, I'm gonna direct you to your resources. So again, in this like really like beautiful resource, like this team is really the best team I have ever worked with professionally. They
Yeah.
are so thoughtful about like what people need to know and how it is most productive for them to access it. I'm continually blown away by this work. So the first thing in there is about counting, and you'll see that there are other mathematical domains, operations that are there, and I'm sure more will be added over time. But it has some of the key features of counting. I think what I'm gonna ask you to do is just take another minute now, and I think this is what I want to do. Take a minute and look at the chart and use that framework to like put your ideas of what Elijah was doing into context.
Can I make let me
Yes.
make another. I would like for you, I invite you to add 2 other dimensions. So these are very visible things: counting sequence, one-to-one principle, and cardinal principle. There are 2 things that are a little bit harder to see that are also a part of the structure of counting, which is order irrelevance and abstraction. Okay? Order irrelevance means it doesn't matter if you start over here, or which element in the set that you start with. If you take care of the whole set, it should be the same cardinality. Okay? And abstraction is also really cool because it says that the objects other than their set membership are treated as irrelevant. I've got one person giving me a head nod. Appreciate you, bro. Do we know what that means? Oh. I thought we were lined up. It's all good. It means that if I'm going to count people, if I'm going to count, I'm zeroing in on a feature or characteristic, and that becomes true of my set.
So it's how you decide, and you can correct me if I'm wrong, how do you decide what the set you're counting is?
What is it?
Right? So is this or is this not included in the
Should I
set
count
of
it?
objects I'm going to count?
Right. So that might have been an abstract feature that he was keying in on.
And I think that's helpful, but I want to stop and let people
talk about
at their tables apply those characters.
I want to talk about it with you right now.
We're going to do that,
Yeah.
but first we're going to give people a chance to do that.
Should we
Go
play
ahead,
it again?
Talk about the video in relation to these characteristics that we just highlighted.
Should we play it again?
Let's play it again after. Let's
Okay.
just let them talk, and then we see it one more time, and then we'll bring it back together, because they'll come up with hypotheses of this happened or that happened, or questions
And
about
then we can
this,
get
and then they
to-
can see it, and then
Okay.
you can go through and make
And then
sure.
after this one is where we're showing that he's he's hitting all of these.
Right, okay.
Except one-to-one correspondence. Well, I don't say he doesn't hit it. I just have
Yeah,
it colored
it's
differently.
developing. That's how
Yeah,
I
yeah,
talk
yeah.
about it.
Right. You're like, I'm gonna rescue secondary.
Let the people talk.
Rescue me again when we do infinity.
Yeah, oh my God. I will not be doing any rescuing that. I'll just be shaking in the corner. I looked through that quiz and I was just like,
No. But they're all gonna get 100. Watch.
no, it's going to be great. All right, I'm going to bring us back together. And our assumption is in that conversation, questions were raised for you, like, oh, I saw him do this, or I saw him do that. And so what we'd like to do is play the video one more time so you can sort of see if what you thought you saw was there, or if you disagreed, to check it. So can I get the Elijah video once again?
Oh, dude, you
Are
got
you
it.
fighting?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
Okay,
12.
count again.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good job. How many you have?
10.
Good.
Perfect. All right, now can I go forward to my slides? Okay. So I want to talk about some of the things that we wanted to highlight here. And you can see if these are the kinds of things you talked about, and then we can add to it. So in the orange list, like, here are the kinds of things we're asking as teachers when we watch kids counting. Like, where are children in relation to these things? So with one-to-one correspondence, I would say Elijah at this point is developing that one-to-one correspondence. We see it as relatively trustworthy with the first 5, and then it gets a little bit messier. This is an entirely expected developmental trajectory if you work with young kids. Stable order, we see that. He has the counting sequence. He does not skip numbers. He feels pretty confident in it. Cardinality. This one, I think, is a little more stable than one-to-one correspondence. At the end, first of all, the shout out to this teacher. She does this really beautiful move of, after he counts them all, she says again, so how many were there? And he says 10 again. This is like such a simple move for teachers in terms of reinforcing that idea of cardinality for kids. And regardless of whether his count is accurate, he has this expectation that the number of objects I counted will stay the number of objects I counted, right? So it's not dependent on accuracy. With abstraction, we mentioned this earlier, he counts the bugs that are in front of him, but not the bugs in the bucket. He counts all of the bugs together, even though some are green and some are brown, and they're like horrifyingly all different kinds. He treats them as, here is a set, and I'm gonna count them all.
And like, how brilliant is that? Like, that's a non-trivial thing to see all of those things as something that can be in a broader set than the thing that it's trying to represent in real life. Those things are trying to represent grasshoppers and lobsters and
I don't
all
know.
sorts of other things.
I try not to look at that part.
But he understands enough to get to a level of abstraction to see those as discrete things that are countable to him that make that set.
And that mathematical
cool.
act can be traced all the way up, right? Like when people write statistics about the economy or about education or whatever, they are making a decision about, like, this counts as part of this set and this doesn't count as part of this set. So it's a skill that begins there and then keeps growing.
Order of relevance.
Order of relevance. So if you, hopefully you've seen it enough times to notice this, Elijah doesn't start the count in the same place both times. It's not a mistake. It's because he knows you can count the set starting in different places, right? So we don't have to say, oh no, go back and start here. And the teacher doesn't tell him to. She says, go back and touch each one, which is, again, a nice prompt for kids developing one-to-one. But she doesn't say, oh, start at this one. Oh, move left to right, right? And we might, like, as a teacher, I might welcome that move because it values the child's agency, which is something that is really important to me as a teacher. But I think in conversations with Maisie, what I've come to see is that it's also mathematically really important, that teaching him that you always have to start the count from the same place is actually not mathematically correct, right? Like, this is where, again, that logic underneath literacy and underneath mathematics is different. Like, we do always read in the English from left to right, but we don't have to count that way. And so, I don't know, making space for like a literal mathematical way of thinking is really important.
Yeah.
Is there anything else that like people noticed that you would like to bring out from the video? I'm not seeing anything, so let's go.
Are you sure? The advanced math part's next. Okay. Could you mic so that there are people
Yeah,
on
Jill
Zoom?
has it.
Yeah, thanks, Jill.
From an early childhood perspective, it's in the context of play. So it's centered in the work the child is doing, the interests that they have, which is the insects and the bugs, and it is working from that first and then moving into some different kinds of observations.
Yeah, and kids are forever interested in how many of something they have and whether it is more or less than something that someone else has. So this is not like a topic we have to work really hard to like get kids interested in. They want to know this. So yes, absolutely, it comes out in play.
We also noticed that he had originally sorted them by color, but was still counting everything all together. So there were other patterns going on as well.
Yeah. We have, yeah.
One of the pieces that was interesting for me is the question was, well, how many bugs do you have? I believe something like that. But then it seemed like at one point he struggled calling the lobster-looking thing potentially a bug, and it was like this quick, like, do I count it? It's a thing there. Do I count it? So that was an interesting piece of, you know, the words that we use as a teacher even, matter, because then that can get them stuck when they're trying to do the one-to-one.
Yeah. If that's your hypothesis, what's a question that we could ask to test that for Elijah? Do you understand what I'm asking? So as you're watching kids do things that are quote unquote simple, if you were to get a teacher to engage with him around that hypothesis that the lobster, we think it's a lobster.
Science is a whole other domain.
Right. that he's struggling with that, maybe because the difference in its size compared to the other toys, or because he's not sure if it's a bug or not. What could we ask? So maybe do a turn and talk and figure out, what would you ask to understand something about Elijah's counting practice as it relates to that set and this comment? You got it? And let's take at least 2 or 3 like really good ways that we would prompt teachers.
That's good. I like that. Turn back to curiosity.
I think it's hard.
It is hard. It's hard because, in my opinion, teaching is so goal-directed, right? We have those standards, and we know we have to get there. And like PK people know they literally have to check these checklists, right? And so it undermines curiosity, because the question you're always asking is, did this child meet this standard, instead of what is this child doing?
Right or wrong? Yeah.
Which is boring, like as a teacher.
Yeah. Back?
Yeah, probably.
Okay, let's take 3 comments. 3 comments. What could we encourage a classroom teacher to do? What could we ask Elijah to test the hypothesis that there's something about the lobster cricket that Elijah's trying to count? What are you thinking about? So we have one right here.
So I guess if my hypothesis is that he paused because he was uncertain about whether or not a lobster qualifies as a bug, I would simply ask about what he did. So I might say, I noticed when you were counting, you paused here for a second on this one. Tell me why. Or I might also just simply ask, are they all bugs? And see what he says.
Okay.
We had like the same idea. We thought he had schema going for himself because he had green ones and he had brown ones separated. And then when he counted, he realized there were 2 groups, counted the first time all the one group, second time the other group. And then we said the same question she just said too.
Can I make an observation? Is there another comment?
I was wondering if he took the lobster bug away, and if you ask him to count it again, what number he would come up with. Like, would he still come up with 10? Would he come up with a different number? So does he know how to count 1 to 1, or was he just not counting the bug and skipping over it and just coming to 10? It might give a little bit more information if you take that big one away.
I appreciate that. I want to make an observation about the first 2 comments and then the 3rd comment. So the first 2 comments are inside of that. I wish I had that. I could like zoom through my slides again. They're using, and the commenter here even said, the schema in the head. So those 2 comments are trying to make reference to what you think is going on in his head. Can you know that? I think everyone, we have to get on the same page. Can you know what's in his head? No. The last comment was relying on I'm not saying either one of these are right or wrong. They're two different views for how we can look at counting. I have a particular bias towards thinking about it as a cultural activity because that's the thing that we can see. And so if we take something away and we change the conditions and the context, and then we ask Elijah to engage with that again, and you may feel differently about this, but what we can observe, touch, we can't get inside his head. We don't know what the schema is. He just might have happenstance put out brown and green. We don't know. And we can't know, but what we can do is engage with kids as a culture, thinking about counting as a cultural activity and talking and engaging with them within that activity.
This is gonna seem a little bit random, but it's a connection I'm just making right now in the moment. I was listening to a podcast the other day, and they were talking about this study where college students were asked to like taste jams and rank them. And then they compared the college students' ranking of jams to like experts' ranking of jams. And I don't know how you become a jam expert, but like apparently people are. And it turned out the rankings were really close. It was like all of the 5 were almost in order with 2 of them flipped. And then they asked like a different group of college students to rank them, but then to write about why they did their rankings the way they did. And this time there was no match between what the college students did and what the experts did. And I will say, as a teacher educator who has like done a lot of reflection about like beginning teachers, like reflect on what happened, this shook me a little bit. And the argument of the researchers was that a lot of what we do is intuitive. And when we are forced to put an explanation to it or put words to it, one, we just make stuff up because we don't really know why we did what we did. And 2, we're often less good at whatever we were doing because we did it. And so, like, as I like engage with what Maisie is saying, I'm thinking like this, explain to me what was happening in your head while you did this thing might actually be counterproductive, and not just like for little kids who can't do this or whatever, but like all the way through the lifespan. And so it persuades me that we would be served by spending more time observing what other human beings are doing and like creating new situations. So like if I wanted to know more about what Elijah was doing, I might think of a new task that I might introduce the next day and sort of see what he did with that, like a different collection of things, and see what came out of it.
Yeah.
Yeah.
Yeah, I love that. And that's like a perfect segue, because what we're going to be doing now is thinking about, is counting really all that complex? Now, what do you guys think? Is it all that complex? Be bold. Someone says, yes. Do we have to do it? Well, there are 2 things that I want you to get out of this activity. One is to appreciate the experience of developing new ideas or simple ideas. And there's no reason for anyone in this room to know a priori, like before you walked in this room, anything that I'm about to talk about. There's absolutely no reason. Some of you may, but I want you to start thinking about what it feels like to start playing with a mathematical object for the first time, or in this way. And the other is I want you to appreciate the mathematics of counting as it leads to really advanced concepts in the discipline of mathematics. Are you ready for it? First question. Counting helps us think about the sizes of stuff, and you already see my question. Are there more margaritas or glasses of beer? Well, the easiest thing to do is for us to line them up. And who said margaritas? We're going out later, yeah.
Won the prize.
You line them up, and what happens if the lines if they all line up? What does that mean? Same size. If one is shorter, there's few. So the size of the sets, if we can line them up, are the same. Everybody in agreement? Feeling good? Okay. The other thing that I want to just tell you is that numbers, this is going to be like, just go with it, okay? Numbers aren't real, y'all. They're just ideas. Oneness is an idea, two-ness is an idea, three-ness is an idea. And we could apply oneness, two-ness, and three-ness to margaritas instead of beer. Or we could just say, hey, it doesn't matter what's in the glass, or it doesn't matter. These are just a set of ideas, okay? Does that feel weird? Good. Great. I want you to move now to the idea. So this is a set of things, right? And it's a set that is well defined. We know what 1, we know what 2, we know what 3 looks like. You know, we got an image of that. But now I want you to think about an idea of an unbounded and limitless set. What do we call that? Infinity. To infinity and beyond. It's this really cool concept, which means it's a set of stuff that just keeps going and going and going and going. But it's not a number, right? A number is well defined. Infinity is just an idea about a quantity. Everybody with me? It's just an idea. We play with ideas in math. So now you get to take your first infinity quiz. You ready? Oh, 2 participants are responding. Oh, and let me just say, we should time this.
Y'all.
This is a
Don't
time
freak out.
test. No, I'm serious. Try to get those in. We need to move right along. $73, you got, no, you don't know your facts. Let's go. I actually can't tell how many people have responded. I thought I could. It's just like how many people are in there right now.
Oh, I see.
Okay, let's take a look at the results. You ready? 5, 4, 3, 2, 1. Okay, 61% of us think that it's infinity plus n is infinity. 63% say infinity plus infinity is infinity. And then we've got a 21% say it's double infinity and indeterminate. 53% say infinity minus n is infinity, indeterminate, and then n. And then multiple infinity, so 57% say it's infinity. And then here we go. How do the natural numbers and then even numbers compare in size? Okay. Are they the same? Can we not know it's indeterminate, or there are more natural numbers? So we're pretty split here. Okay? Don't worry. I'm going to do some direct instruction. Okay?
We hear that's magic.
Yes, it's magic. I'm not going to do that crazy unguided inquiry. I'm going to do some direct instruction. And do you have your notes out, pens ready? Here we go. The size of a set is called its cardinality. The cardinality of an infinite set is in, very good, look how good of a teacher I am. The natural numbers have the same cardinality as the even numbers and the odd numbers. I'll repeat, because it will be on your quiz, that the natural numbers have the same cardinality as the even and odd numbers.
Maisie, I think you should have them repeat that.
Oh, class.
That's how learning happens.
If you say it 3 times, it's magically in your brain. Here we go. Start with the natural numbers have the same cardinality as the even numbers and odd numbers. Gosh, I'm so good at this. And then finally, there are different sizes of infinity. Look to your right. Those are your infinity facts. Got them? Any questions?
Yes, ma'am.
Too bad. Take your quiz again. The highest we had was 63.
Yeah. I should have written them
Oops.
down. We'll get better at this. 100% Maisie.
I know, I'm such a good teacher. I think we can push forward. What do you think? Oh my gosh. Look how amazing I am.
That growth in such a short time.
In such a short time period. We're gonna find that 1% and we're gonna get them out of here. Move them. Look at that. 98%. 98%. I was a teacher in Texas, and your bonus structure for how you got paid was based on your students' standardized. I would be cleaning up right now. Natural, 95%. Okay? Pretty amazing, right? Because if we think about this, and this is, Amy and I are gonna do a soapbox moment. For a 5-item quiz with 3 choices, there's only a 1% chance that you could get 100 and just guess. And there's about a 4% chance that you could get a 75, and then there's a 50% chance that you could get a 50. So we're not gonna pay attention to anything less than a 50 because all of that is just pure guesswork. But based on the fact that you guys were in the 90th percentile, what does that mean? It means you actually learned something.
You know infinity.
You know infinity now. Awesome. Is learning growth on an assessment? Oh, I thought you were gonna have an immediate response from me. Is learning growth on an assessment? Have you learned something? Why do you say that?
Which was the infinity, but you said infinity is different sizes. So I still wanted to put indeterminate on there because I can't determine the sizes that were on there.
I told you exactly what you needed to know. I read it to you 3 times. I gave you the facts.
You read it out loud.
Look,
you were engaged.
What is going on?
And I have the data that says you learned. I could put those little things up on the wall and move them.
Look at the dials. Look. You guys were way over there, and now you're way over there. Wow. Why is direct instruction and explicit instruction so sexy? Why? No, I'm being like...
No, but for
I'm
real.
actually being serious, and I was about to rant, but then someone laughed. Why is it so sexy? You'd like to know the answer? Did it feel satisfying to know the answer? Yeah. You trusted me to tell you the right thing. It's easy to keep track of. It's easy to evaluate. And what does the evaluation provide us? some pretty awesome results very quickly, and yet you all don't know infinity yet. So I could keep going on this. I think I'm about to go on a tangent rant.
Actually, come to our breakout tomorrow if you would like to see both Maisie and I absolutely lose our minds over this stuff. That's the plan.
But the other plan is to say that I want to unsettle the notion that you actually understand what infinity is, if this is a new concept for you. And so now I'm gonna do, because there is no binary, all of these things are on a spectrum, and we could think about interactive direct instruction, and we're gonna build a little bit more understanding, but it's still gonna be through some, because I have another like 5 minutes, I think. But the thing that I want you to understand is, like, in the same way that we can line up those margarita glasses and beer glasses, and this is why the natural numbers and the even numbers are the same size, notice what we can do. If we can map, just like we can map a margarita to a beer, and if we can map the natural numbers to the even numbers, what does that mean? That for each natural number and each even number, that there's a one-to-one mapping, just like there's one margarita and one beer. What does that mean? They must be the same cardinality. They've got to be the same size. Does that make sense? It feels weird, right? Because you're playing with a set of mathematical objects in a new way. Even though one-to-one correspondence that we ask small children to do seems very simple, now that we're trying to do that within a new context, it might feel for some of us a little bit weird. And so we can say the same thing about the natural numbers have the same size or have the same cardinality. We could say the same thing about odd numbers. I'm gonna tell you that we could say the same thing about the rational numbers. Because if we figure out, and this is what mathematicians do, how to write these in an ordered way, and then to count and to assign a number to each of one-to-one correspondence between each of those elements in the cell, and we count it in a specific way and put them into one-to-one correspondence, guess what we find? That the rational numbers and the natural numbers have the same cardinality. They're the same size infinity. Oh, come on, y'all. Okay, if that doesn't blow you away, then this will. We've been playing with the natural numbers and the rational numbers, but let's play with the real numbers. And here's the thing. The infinity between zero, I'm not gonna prove this to you because we don't have time. And Amy's thinking, thank God, make her stop. The infinity between 0 and 1 has a larger cardinality than the infinite set of natural numbers. We can't put all of the real numbers between 0 and 1 in one-to-one correspondence. I'm not gonna prove it to you because we don't have time, but there's tons of videos out there that are way more compelling than me. And the mathematician who discovered this, he was lambasted. People couldn't stand him.
Because, like, I just have to ask this.
Yes.
the even number infinity and the natural number infinity are the same size.
Yes.
But this infinity is bigger.
Yes.
All right.
But this is foundationally how we start to get kids to conceptualize what infinity means. And it means starting with the definitions of mathematical objects, which means cardinality and size as we think about it on a number line. Those things become anchors that pin us down. And now the math is starting to get more abstract and float up. And so those old images, schema, are holding us away from moving forward. And this happens for kids all of the time. Because we say things like, you can't subtract one number from the next. And so those things get disrupted over and over again. But that's the feeling that you're feeling, children get that all the time. Okay? And so my goal was for you to think about two things. The places on red, how are we doing? We're doing okay. The places that are red, that's where I had a friend of mine who's a mathematician but also does work in K-12. I was like, mark this up. Where do we actually study mathematics if we understand these to be all the topics of math? And you see the little star, you are here? That's the work of the people in this room, okay? And the thing that was important to him to say to me is that most of the time, even though there's a circle there, he was like, I don't even think I should put calculus here because most kids in the United States actually don't take calculus. But look how vast. Let me show you another picture. Do you see those black dots? Those black dots are the places in which we actually spend our time in K-12 mathematics. And look how big math is. Here's another image. The places that now we're touching on a lot of little things, but do y'all remember how many of y'all actually got to the end of your textbook and actually did statistics? Come on. And for and for those of you who taught at secondary, you never got to statistics. So this is an overrepresentation of the things that we do. But the other important thing that the mathematician friend of mine shared, it was Matt, Deborah, shared, was that the things that you all work on with kiddos is the foundation for all the rest of this picture. And so I just want to hype you up to say these seemingly simple ideas of one-to-one correspondence may have felt new and created new ways of seeing. This is happening for our young learners. That was my first point. But the second point is mathematics is a vast discipline, and we barely touch its vastness in K-12. But to the extent that we touch on things, the role that you all play as early math education, is profound. Because if you don't do the work that you're doing, they don't get to the outer edges of this map. You know that already, but I just wanted to say, counting is important. To infinity, y'all. Okay.
All right. So I'm gonna bring us back into the worlds of our little people and think about how do we take seriously the ideas that Maisie is bringing to us, which I think include both the bigness of mathematics and our children's curiosity about it. This is another little sidetrack, but sometimes the idea of developmentally appropriate or culturally relevant instructions gets made so small that it treats children as if they can only be interested in the number of cookies they have or whatever. But the truth is, children are vastly curious about the way mathematics works. They are interested in patterns. They are interested in figuring things out. And so part of what we need to do in our math classrooms, I think, is create a space where both our children and we can be curious about this huge mathematical map that's out there. There is so much to learn and think about. And then the other thing, as adults, we need to be curious about children and what they are thinking. So we were having a side conversation during one of the turn-in talks, and I was saying it's so hard as teachers to be genuinely curious about our kids because our standards and our assessments are always in our heads. So often when we are looking at children, even when they are playing, we're thinking, what can I check off on my little developmental checklist, right? To say they've done the skill, they've done the skill, they've done the skill. But if that's my mentality, I'm not actually curious about my kid and what they're doing. I'm only curious about, are they meeting the things on this checklist? And I recognize how hard and complicated. I also had my first teaching job in a state where our raises were linked to our kids' performance. So like, I get it. But if we can help teachers make this shift, not only does it make mathematics more engaging for kids, does it make classrooms more fun for kids, but it actually makes teaching more fun for grown-ups, right? Like, we need to start asking teachers and supporting teachers in doing things that make their jobs better instead of things that make their jobs worse. So that is what we were going to focus on with our last 10 minutes. This is a video, I hope, of kindergartners playing in a classroom. They're building a tower out of magnetiles, and they decide to count how high it is. And what I'd like you to do is to watch it and just to think about, what are you curious about mathematically in this interaction? And not even what would you do about it, but just what are you interested in? All right.
Dude, this is a dog. It's not a Billy. Wait, so what happened? Dude, what is this blue rocket ship? 1, 2, 3, 4, 5, 6, 7, 8. 8 levels is bigger than 8 levels. 8 levels. 1, 2, 3, 4, 5, 6, 7. 7 levels. I thought it counted too much. 1, 2, 3, 4, 5, 6, 7, 8. No, that's the roof. Yeah, I know. Layers in the roof. The roof don't count.
All right, so just at your tables, what are you curious about? What hypotheses do you have? What would you like to know? What are you interested in? Go ahead.
We're doing great. We have
I know, we're awesome.
like 14 minutes. Perfect. Yeah. Do you think we'll have time to do the last video?
I think we will.
Yeah. Yeah. Did I drone on? Oh my God.
No, you did perfect. You did perfect. I thought it was exactly the right amount of interesting, at least for me.
Yeah.
Like, even though I don't know a lot of things, I am more curious about a lot of things than most people are. So I don't, but it
I
felt
don't know
right
that
to me.
people were. Yeah. We'll have to ask.
Yeah, well, that's why I thought I would break in to model my surprise, because I was genuinely surprised.
No.
Because after all those problems where everything was equal, then all of a sudden to have one where it's not equal, that's weird and they don't like it.
Yeah.
Which I guess is how mathematicians feel. So.
I mean, there's all of this time trying to come up with different methods to prove whether or not it's accountable, those are countable sets or uncountable. And so uncountable infinity is bigger than countable infinity. So
It really is. But what you just said, so it's because you can line something up with all of the natural numbers, but then there's still more because it's uncountable, and that's what makes it bigger.
Right.
Is that
That you can order them, and that one number only maps to another. And if you can establish a method of doing that, then you've established the one-to-one set as a cardinal set that is the same size. But if you're unable to do that, and so then you have to be able to prove that you're unable to do that kind of one-to-one.
I'll show you my tattoo. That's awesome. All right, let's come back together. So let's just hear, like, from 3 people, what are some things you were interested in this video, questions that were raised, curiosities that were sparked?
All right, so had a wondering at our table about the language that was used about hotels and roofs and why the roof don't count. Wondering if, as a child who's never seen an 8 or 7-story hotel, like a skyrise, how they would maybe think about or approach that problem differently. And it almost seemed like maybe there was some understanding that a roof don't count because when we talk about levels, levels are where people are, and hopefully there's no people on the roof. Maybe there's a reason for that. I don't know. But so we had a wondering about how these children, if they maybe lived in a more urban setting where they would see those things or have experienced them in their lives, Versus I know we have some folks at our table that are from very rural settings and wondering how our rural children who maybe have not had these experiences with high-rise hotels might have a different take or reference as they thought about this.
Yeah,
activity.
and so like I would say that's a mathematical question because it's really about how are these kids defining the set that is counted and what was their thinking behind it, and that's interesting. Two other things that spark curiosity for people.
So I am still in the era in my house of magnet blocks with my own children. And so my curiosity was when the little boy was counting on the side, I know that my kids run out of squares and end up using triangles to create more squares. And so I was curious, was he actually counting, what did they define as the level? Or was he actually just counting, like, was there triangles over there that he was also counting? Or were they actually squares?
So other questions about defining that set. How are they thinking about it? Not just in terms of like building geography, but mathematical pieces. One more. Behind you.
How could they both be right? That might be a question that you pose to them.
Yeah, and like maybe bring to the whole class, like I can imagine kindergartners being really interested in a conversation about can there be two right answers to a math problem? And like that would be like a genuinely mathematical inquiry to engage 5-year-olds in. Okay, can I go to the next slide? So I want to bring it back to what we're doing here this weekend. You have this framework on your table, which you're going to be talking more about in the next 2 days. But what it is, I think of it as like a possibility for elementary mathematics instruction. So this is not like rules you must follow, but it is a way of thinking about if I'm going to take the essentials seriously, what might it look like to use them in a classroom where we have 40, 50, 60, 70 minutes for mathematics? And what we would like to encourage you to do, like taking this session forward for the next 2 days, is to think about how each of these pieces can be understood as an opportunity to take children's mathematical thinking seriously and to follow or to have your own curiosity about what children are doing. So if we're thinking about number sense routines, how do we implement a number sense routine in a way that honors children's thinking and our curiosity about them as opposed to trying to get everyone to the right answer on the same page? If we think about designing cognitively demanding tasks and doing our launch, explore, discussion sequence, how do we make space in that sequence for different children thinking in different ways, for sharing their ideas, for us as teachers finding out about what kids are thinking, and even as we think about fluency practice, not to set anyone off, how do we think about creating opportunities to practice fluency in our classrooms in ways that let children be curious and let us be curious about them? And so I think we want to sort of suggest that as like a framing lens as you move through these 2 days. Did you want to jump in there?
No, I just felt like that was a perfect segue to the last video.
Okay, perfect.
Yeah. And so this was like the way that any good person starts a talk to an audience of this is you get on Google and you go to YouTube and you look up, that was the laugh line, you guys, get with me. You go to YouTube and you find videos of children counting. And so I want you have new lenses now and we have new respect for what kids are doing when they're counting. And we can laugh, but then I also want people, just as these are playing, to yell out the feature of counting that you see. So you might be like, one-to-one correspondence, abstraction, cardinality, but I want you just to say it out loud as you're seeing what kids are doing.
And I see some people moving to get those counting frameworks in front of them that may be helpful to you as you're doing that.
So we've got one-to-one correspondence, stable order, cardinality, abstraction, and order irrelevance. And we want to think, I think to the point earlier, how kids are playing towards these different concepts. Just yell it out.
13, 16, 11, 12, 13, 16, 11, 12, 16.
Stability.
Say one.
Num.
One.
Num.
One.
Num.
Four.
Door.
Four.
Door. We went to the
Counting in his
donut
own
shop.
language.
You did? And what'd you get?
Donuts.
How many?
68.
68.
And then we went home, and then we had 128, and then we had 160, and then 154. 13, 14, 15.
You say 5.
What's one in Spanish?
I know.
Uno.
Uno.
What's two in Spanish?
Uno.
What's three in Spanish?
Trio.
Can you count for mommy?
Perfect. About one.
Can you say one? One.
Two. Oh, there's all your money, Jack. You want me to count it? I'll count it.
Scarlett, count backwards.
1, 2, 3, 4.
Josie, what did you get?
What is it? It's 100 money.
100 money?
I said 8 plus 4. You said it was 14. Is it 14?
Yes,
Okay, show me.
because 8 plus 3 is 13. 98, 99.
What's next?
20.
100. Kayla, you just counted to 100. How do you feel?
50. 20. 20. 20.
30,
21.
33.
No, 21.
What are you doing right now?
Seeing how you can in your
Showing me how to count in your head. Okay, do it again. Count in your head.
you don't move.
Wow.
So I love the way that ends, because counting in your head and thinking that mathematics happens in the head and not in that social space, not in that cultural space where language is happening, where kids are using their imagination, that's where counting is happening. And so I love that she's doing a lot of counting that we'll never see if we're not engaged and following kids. And so that's us.
Yeah, I think the last thing that I would say about that video is the thing that stands out to me, and this will not be surprising to anyone, is how much joy you see from the kids as they engage in this, and the way the adults in relationship with them, and granted they are like family members and not teachers, but do not leap in to like immediately correct them, right? They're like delighted by the kids' approximations. And I think that as we bring together joy and delight with our mathematics teaching, it's not like chocolate-covered broccoli, where we're like trying to get the math into the kids, but it's actually an opportunity to engage more deeply in the mathematics. Like that is in fact more joyful. And so I hope that like that is how the rest of these 2 days feel for you, and also your work with teachers across the year.
Yeah, thank you all so much. I think we have time for a few comments or questions, but I don't know if Sonia, oh, sorry, nope.
No, we have a few minutes.
Okay, yeah, did anyone have comments or questions? We're happy to entertain. We did get on time, and so I was like.
I know, it was amazing.
You want to take another quiz? We appreciate you all so much. Thank you.
Thank you so much. Thank you so much, Dr. Gholson and Dr. Parks, for sparking curiosity in children's mathematical thinking and for taking a deep dive in counting and infinity. So let's give them another hand. We are going to take a 15-minute break and come back here at 10:45. There's plenty of coffee and water. Please stand and stretch. And then we'll dig into how teacher learning might unfold around these ideas.